Hello, everyone. I think we are live. I'm just trying to check here that everything is working. I think we are live. So this is the first time I broadcast by myself, so please bear with me. So I'm doing this by myself. It's going to be interesting. Thank you so much for joining to this Global Azure virtual event in 2021. My name is Paco de la Cruz. I work for Deloitte Australia, and today we're going to be talking about how to implement custom distributed tracing in Azure Functions using App Insights. So I hope you've been enjoying the different talks as part of this Global Azure event. There are hundreds and hundreds of sessions from all over the world in many different languages, and I'm so excited to be part of this initiative. So let's get started. So as I mentioned, my name is Paco de la Cruz. I'm a Microsoft Azure MVP. You can follow me on Twitter or on LinkedIn. I also have a personal blog, pacodelacruz.io, and I also have a GitHub with multiple repos. The slides of this presentation are already shared on my live share space, so feel free to have a look at them. The agenda for today is, first I'm going to give an introduction of why we should consider implementing a custom distributed tracing in Azure Functions using the integration with App Insights. Then I'm going to be describing the scenario we're going to be using for our demo. Then we're going to be discussing different or common requirements that we hear from teams from operations when they are dealing with these solutions in production. Then we're going to go deeper into the design of the tracing strategy. So we're going to be covering the different spans in the tracing strategy, also the different key value pairs. Then we're going to be seeing the solution design, the sequence diagram, and the different components that are part of the solution. Then we're going to have some fun with the demo, and hopefully we have some time for a Q&A, which is going to be interesting in this virtual world. Let's see how that goes. So first, why are we talking about implementing custom distributed tracing in Azure Functions? Well, first, as developers, we tend to focus on shipping to production, right? So we focus on having zero bugs and a great quality solution deployed to production. But then what happens after that, we tend to forget. And when we deploy the solution to production, then this becomes someone else's problem. However, if we think about distributed systems, where we have multiple components that are part of our solution, we need to be aware that these will eventually fail because of network issues or because one service is down or multiple services are down, right? So we need to give our operations team the means to troubleshoot this solution. And this is particularly relevant when we are deploying solutions that are running in the background. So think of Azure Functions that are running in the background, listening to messages in a queue. And if there are no users interacting with this solution, then we might never know if the solution is failing or if there are any errors. So having a very intentional and well-designed logging and tracing strategy is very important. So what I'm going to be presenting here is very well described in a series of blog posts that I have published on the Deloitte blog. And the demo is also available on my GitHub repo. So feel free to have a look after this session. And if you have any questions, if you're going to go and dig deeper into the solution and how it is implemented. So if you feel that you're getting lost, just go to this reference and hopefully you'll understand the whole solution end to end. Okay, so what are the participants of this solution? So think of this scenario as a publish subscribe solution where we have a HR system that is publishing events as batch via webhook. So let's say every time a user event or a user is updated on this source system, then this source system pushes these events as a batch, right? And then we have a target system that is interested on these changes on the users. However, this target system cannot support or cannot receive HTTP calls. So we have an integration layer in the middle that is listening to these webhook calls, and then is debatching this or splitting this call, and then sending individual messages to a service bus queue. And then we have a subscriber Azure function that is listening to this queue, subscribing to these events, and then pushing these events to the target system directly into the database, right? So this is more or less the scenario. So again, we have a publisher of events, which is publishing via webhooks, and then we have a target system that is not able to receive these events, and then we have an integration layer, which is Azure Functions and Service Bus for temporal decoupling. Some notes about this scenario. So the first one is, this is a very opinionated approach. So what we have here is based on many years of experience, right? But it can be tailored to your scenario. We're following a publish-subscribe pattern. So we have a publisher, we have a subscriber, and we also are following the splitter pattern, meaning we receive a batch of events, and then we split or debatch this single message into multiple events, and then publishing this to the target system. And this is relevant when we're implementing this custom distributed tracing, because we will be able to see how this batch of events is being tracked for every single event as well. And as I mentioned, this is an opinionated approach, but it can be tailored to your needs. And it could be tailored to, for example, request response APIs or different type of scenarios or even integrations. So let's start with the high-level sequence diagram with these participants. So on the left, we have the webhook. And on the right, we have the target system, or webhook and source system. And then on the right, we have a target system. And then we have the publisher Azure function, we have the subscriber Azure function, and we have the queue, right? So the webhook is posting an array of user events to the publisher Azure function. And then the function validates the request body. And then if the request body is valid, then it returns, if it's invalid, it returns 400 bad request. If the request body is valid, then it debadges the request body into single events. And then for every single event, it sends a message to service bus queue, right? And then if all events were delivered successfully to service bus, when we return 202 accepted, otherwise we can return 500 internal server error to the webhook. And then asynchronously, the subscriber function is listening to the queue, and then for every single user event message, we're pushing this to the target system directly into the database, and then we expect an acknowledgement. And then if once we push that message to the target system, then we complete the message from the queue. So I hope this is making some sense. So in a solution like this, we might have some common requirements from the operations team, right? So the team that is going to be supporting this in production. So the first one is the ability to inspect the incoming request payloads for troubleshooting purposes. And for this, we can archive all request payloads as we receive them. The second one is the ability to correlate individual messages to the original batch and understand whether all these messages in the batch were processed successfully. So for this, we can capture the batch record count. So let's say we have 50 individual events in the batch, so we can capture that. And also we can assign a batch identifier, and then for every single event that we're tracing, we're going to keep capturing this batch identifier for these individual messages. The next one is the ability to correlate all tracing events for every individual message, right? For this, we can capture a tracing correlation identifier in all the events that we're tracing for every individual message. The next one is being able to find tracing events for a particular message. And for this, so if, let's say we capture business metadata like message type, interface identifier, entity identifier, then we can search for this. We can be able to search and find information about how we're processing this message. The next one is they want to receive alerts when certain failures occur. So for this, we can capture granular event identifiers, right? So we have our code workflow. So for each of these tracing events that we are logging, we can have a very particular event identifier. And we can be storing this in our traces, and also we can store event status. If the tracing event was successful, or if it failed, or if the attempt failed, and so on and so forth. The next one is the ability to differentiate transient failures from non-recoverable failures. So for this, we can capture a delivery count when messages are being retried to identify whether additional attempts are expected or not. And the last one is the ability to filter and troubleshoot what happens to individual messages. This is kind of the summary of everything that we discussed already as part of this slide. So we can enable correlation of tracing events with standard tracing checkpoints, having granular event identifiers, statuses, and business-related metadata. So this is like a summary of all these requirements. I'm hoping this is making sense. Okay, so in order to establish our tracing strategy, we're following some of the open tracing concepts that are part of their specification. So let's start with the spans. A tracing span is a primary building block of a distributed trace, and it represents an individual unit of work that is being done in this distributed system. So in our solution, across time, we have 3 different spans. So the first one is the batch publisher span, and this is a span that is in charge of receiving the batch of events, splitting the message into multiple events, and then it finishes when all these events were delivered. So that's the batch publisher. And then we have the publisher span, which is in charge of receiving one single event in the publisher interface once these have been debatched, and then does the validation and all that, and then sends that message into the queue. So that's a publisher span, and the publisher span is a child of the batch publisher, and the batch publisher would have many publisher spans as children. And then we have the subscriber span, which starts when we receive the message from the queue and all the validation until we deliver the message to the target system. And the subscriber span follows from the publisher span. So now that we understand the spans, let's go deeper into the key value pairs that we're going to be using in our tracing or structure logging strategy. So we're going to be using structure logging to have multiple fields that we can query and analyze and all that. And as part of these key value pairs, some of them will have a scope of cross-span, meaning that these values are going to be kept across multiple spans. Right? So for example, the correlation ID or the entity type. So these values won't change across the different spans. And then we have those key value pairs that have a scope of a span, meaning the same value is kept within the span. And then those that have a scope of log means that the value is only relevant to that particular tracing event. Yeah. So let's go one by one. So batch ID is a batch identifier that would help us to correlate individual messages to the original batch, right? And this key value is highly recommended when you're using the splitter pattern. The correlation ID is the identifier we're gonna be giving to every individual message, right? And this correlation ID will be kept for these individual messages across all the spans. In this case, the publisher span and the subscriber span. Then entity type is the message type that we are being processed for. In this case, we are processing user events, but the solution could have purchase orders, invoices, and so on and so forth. Then entity ID is the business identifier of the message. So in this case could be user ID for user events, or purchase order number for purchase orders, or invoice number for invoices. Right? All these key value pairs are cross-span. The next one is interface ID. So this is a business identifier for the interface. So if you have a enterprise-grade solution of integration, then you might want to assign an interface ID to all of your components or interfaces. And this would allow us to filter or query traces for a particular interface ID or interface. Record count is optional, and this is only applicable for the batch publisher span. And this captures the number of records that the batch has. Then delivery count is optional again, but this is only applicable to subscriber events. And this is, for example, when we are retrying the delivery of the message, we want to know how many times this message has been delivered. The next one is log level, just to know if this tracing log is an error, is a warning, or is an informational. Next one is span checkpoint. So we're going to have 2 checkpoints per span. So when we start the span, when we finish the span, so for example, publisher start or publisher finish. And having these standard checkpoints would allow us to have these correlated tracing events, to query these correlated tracing events in a standard or structured way. The next one is event ID. And the idea is to capture the exact event in our code workflow to help us analyze or query or troubleshoot the solution with greater granularity. We'll see this in the demo. And the last one is the status. So the idea is to store the status of the tracing event, if this event was a successful event or a failed event. So here are the components of the solution. So we already discussed, we have the webhook and the target system, and then we have the integration layer in the middle. So we have the publisher function, the subscriber function, and the queue. So now we're adding the observability components. So we're going to be using a blob storage for archiving the payloads as in the batch format. And we're going to be using application insights to capture all our tracing logs. So let's go through the publisher interface sequence. Right, so we have the webhook, we have the publisher function, we have the queue, but now we have the app insights to capture the diagnostic logs, and then we have the storage account to archive the original request payload. So the webhook will post the array of user events, and then we will capture the batch publisher start event, right? And the event ID would be batch publisher received succeeded. So this is very granular again. We'll see this in the demo. And then we will archive the request body. We validate the body, and then if the request body is not valid, then we send an error in the batch publisher finish checkpoint with a failed status, and we return a 400 bad request. If the request body was valid, then we debatch the request body. And for each event, we send a publisher start. So now we're starting the publisher span, right? With a succeeded event or a status, sorry. And then we send the event to queue. And then if it was successful, then we send the publisher finish checkpoint with a succeeded event, status. if the delivery failed, then we have the same checkpoint with a failed status. And then once all the events were delivered successfully to service bus, then we finish the batch publisher span with a succeeded status, and we return to accepted. And in the case there were any exceptions in the process, we capture the batch publisher finish checkpoint with a failed status, and we return 500 internal server error. So I'm hoping this is making sense. So now let's go into the subscriber interface. So this is from the queue into the subscriber function, and then the target system, and then the diagnostic logs. Hi to the people that are joining from India. Nice to see you here, and thanks for saying hi. Akshay, nice to see you here, and thanks for saying hi. So this is the subscriber interface sequence. So we have the subscriber function reading from the queue, and then for each event we're going to be sending the subscriber start checkpoint to the logs with a succeeded event. We validate the message for the target system. So here we are simulating a process with the target system. So we're validating the message, the payload, if it's stale or not, in the dependencies. So the first thing to validate is if the target system is unreachable. And then we also check if this was the last attempt delivering the message or not. So if it's not the last attempt, then we have the subscriber delivery finish checkpoint with an attempt failed status, meaning we're going to keep retrying. But if it was the last attempt, then we send the subscriber delivery finish checkpoint with a failed status. If the target system was available, then we check if the message was valid or not, and then we send a failed status if it was invalid, and we declare the message. And if it was valid, we check if the message is still relevant. So let's say we're processing these events, and then we might receive these events out of sequence. So if the message that we're receiving is older than one we have in the target system, then we classify this message as stale. So we send a warning to the logs, we discard the message, and we complete the message from the queue. We also check dependencies, and again, we check if it was the last attempt or not, and we send the corresponding events to the tracing logs. And then finally, if the message is valid, we try to update the target system, and then and then we send the corresponding events to the tracing logs. So if it was successful, we send a succeeded status, or otherwise failed or attempt failed, depending on the number of retries, and then at the end we complete the message. Are there any questions so far before we jump into the demo? Okay, I'm going to continue in the demo, and then if there are any questions, feel free to send them via comments. I'm going to show you. So I'm using VS Code here, and I'm using the REST client extension. And this extension allows me to send HTTP requests to my backend, to my function. So for example, I'm gonna say global Azure 300. So I'm gonna change my prefix for my payloads. Then I'm gonna send this one that has an empty array. So this should return me a 400 BAT request. Yep. So it returned already 400 BAT requests, and I'm gonna send this that has a proper array here. Okay, so now the function is running. So I'm gonna show you the code now. So I have a publisher function, and again, as I mentioned, this is already published on my GitHub repo. So if you're interested in the code, you can have a look and copy the code or clone it or fork it and work with it. So this is a HTTP triggered function, and we're using as an output binding service bus with a message collector, right? Because we're going to be sending individual messages to the queue based on what we receive from the batch. So first we get a batch ID, getting it from the invocation ID from the function. Then this is where the magic happens. So we are using an extension method here. I'm gonna step into this extension method. So we're using log structure, and here we have different params. I try to add all these comments for you to understand what's happening with in the code, right? So you will be able to see all these comments in the code. So the first one, we are sending the log level. Again, this is just if it was information, warning, error, and so on and so forth. Then the next one is event ID. And this is where we have very granular event IDs for the different events that can happen in my code workflow, right? So we have an event name and an event ID enum as part of an enum. And then the next one is the span checkpoint ID. So for each span, I have my start and finish checkpoint. The next one is the status of my tracing event. If it succeeded, if it failed, if it was an attempt that failed, and we're expecting more retries, or if the message was discarded. And then the interface ID in my demo, I only have two, right? The user event publisher one and user event subscriber one. But in a proper integration solution, I might have much more than this. And then entity type, again, this is a demo, I only have two. So this is for the batch and this is for the individual messages. In your proper solution, you would have more like purchase order, invoices, and so on and so forth. Then the batch ID, the correlation ID, the tracing event message, the delivery count, and the record count. And then I have, this is my template that I'm using for my structure logging, and we're going to see how this is being stored in App Insights to do all the analysis and query and all that. I have another extension method for the error that accepts an exception as well. Okay, so in this case, we are logging the batch publisher start checkpoint, right, with all this metadata. And then we read the request body and we archive it to blob. This is just to archive the request payload as we received it. And then I'm putting most of my logic in a method that I can test in isolation, right? So this is where all the business logic happens to process this user event publishing. So I receive the events as a JSON and this metadata. I try to validate the message, deserializing it into my object. And then if it fails, I return 400 bad request. Then for each event, I get a correlation ID, which is the invocation ID, an ID that they provide in the request, and then the ID for the particular event. So this should be unique, right? And the message ID, which is also unique, is based on the event ID they provide, and then this is the batch ID, and this is the ID of the user event. And then we have the publisher start checkpoint here with the different metadata. We prepared the message body for the services message. And then we also add user properties here and some headers in the message. And this is important because you remember we had some cross-span key value pairs. So the idea is to keep these cross-span key-value pairs as message properties. So these will be kept for the subscriber interface, and the subscriber interface can receive this metadata and then use it for logging and tracing and all that. And then we return to accepted. So, and then we check if no messages were received, then we return invalid request body. Otherwise, for each message, we get the properties, and then we send each of the individual messages by the queue collector, and then we log the publisher finish with the corresponding message. Once we finish all these as part of our for each loop, then we log the batch publisher finish, the checkpoint of the batch publisher span. Then we also have catch here in case there is an exception, and then we send the corresponding error. So this is a publisher interface. Now let's go to the subscriber interface. So the subscriber interface is so this has a service bus trigger, right? So we trigger this function every time we are receiving the messages from the queue. And this is the method that has all the business logic. So we receive the message, and we get the delivery count that we're going to be using for our traces, and then we get the values from the user properties. Again, this is for the cross-span properties. Then we read the message body, and then we start our logging, right? So this is a subscriber start event or checkpoint. We check if this was the last attempt or not, and then we send the subscriber finish. And then we have here a method that is simulating because we're not delivering to the actual target system, we're just simulating this. So based on some randomness in some fields in the request body, we send different errors or different statuses to the process. Yeah. So this is pretty much the implementation of what we saw in the sequence diagram. So again, this code is available on GitHub. And now let's see how this would help us to get something in our solution, so to monitor the solution. So let's start with my resource group. So this is my resource group. We have an Azure function, we have app insights, we have service bus, we have storage account, right? And then we have the workbook. We're going to see the workbook where we have all these queries. So let's start with the storage account quickly. So if you remember, I sent this request, and then I provided, well, we received a activity ID as part of the response body. So we can check the request that we received based on this ID. Yeah, so we can see here, and we are archiving all the request payloads as we are receiving them. And this is to provide all this observability and capability to troubleshoot the solution. So we can see here the payload as we received it, right? So that's the storage account. So now let's go into the App Insights. So on App Insights, I have this workbook that I published as a troubleshooting guide. And then on my troubleshooting guide, I have this one that is the one that I created. And this is where we can see all the benefits of having this distributed tracing strategy. So for example, here, thanks to having all this business metadata in all our tracing events, we can see the message count per entity type. So for example, we can see here how many how many user updated events received per hour, right? And then overnight we didn't receive anything, and now we started receiving some messages at 7 a.m., right? So we can see here we received 107 of this type and then 10 of this type. And we can have a look at the query that is rendering this chart. So we're checking the traces. We check where the span checkpoint ID is publisher start, right? So this is where all this metadata is bringing all this value. I project these properties and then I summarize the count, right? With a time being here, right? So, and then I can render this as a chart. So the next one is how many errors we're having per interface ID. Yeah. So again, this is very similar, but where the status is failed, right? And we just group by count and interface ID. And we can render this as a chart. So this is what we get, right? So 98% of the errors are in this interface, and then to 1.2%. I'm simulating all these errors to show you the value of having this structured logging as part of our distributed tracing strategy. And the next one is error count by event ID. So the title is here is incorrect here, but should be interface event ID. So we can say that for the subscriber delivery failed unreachable target, we have 114 in the last 24 hours, and so on and so forth. And again, this is the value of having very specific event IDs that we're using a different correlation structured logging events, right? So we can analyze and troubleshoot what's happening. And we can, with this data, we can see if this is a bug or if this is a problem with the messages we're receiving, or if this is a problem with the network and all that, right? Very similar query for this. Now we're grouping by event ID or event name. So the next one is showing us the failed traces, right? And it tells you the interface ID, the event entity type, entity ID. So for example, we know that the target system had some updates on user number, user ID is 14, right? And we're not receiving that change in the target system. Then we can see here. So we received an event for user updated for user number 14, and we can see the reason why we're not seeing that event in the target system. And if we go into the logs, sorry, the query that is behind this. So forgot to mention, I'm using here custom queries, and custom queries is the language you use to query app insights and monitor logs and log analytics and all that. It's very, very powerful. So from traces, I'm sorting by timestamp. I'm filtering where the status is failed. I'm projecting these properties. And all these properties is what we're getting as part of our structured logging strategy. And then I can have optional filters here. So for example, I want to see, give me all events where entity ID equals 14, right? So I can query, okay, give me all events where we were processing the user ID 14, and I can see what's been happening with this. Very, very handy when you are troubleshooting solutions in production. Or you can say, give me all errors for this interface ID or for this correlation ID, and so on and so forth. For example, I know that was my correlation ID, right? So I can say, give me all errors that happen in that correlation ID for this user with user ID 14. So all these queries are very, very handy. As you can see, the results are returned very, very fast. So the cost of query on App Insights and Azure Monitor is really, really powerful. So the next one is correlated traces, and this is very interesting. So you can see here, I'm correlating the different checkpoints for individual messages, right? So I can see for the user updated event for the user 16, the publisher start checkpoint, publisher finish checkpoint, subscriber start checkpoint, and subscriber finish checkpoint. And I can check the event name for each of these checkpoints. I can check the status for each of these checkpoints. And I can check the delivery count, if it was the first attempt or the second attempt. And let's have a look at this query. So we need to consider here that each of these events, each of these checkpoints is a different record in log analytics. So let's have a look at the query. So again, we're checking the traces. We start with the publisher start checkpoint. We project all these properties, and then we do a left outer join with the publisher finish tracing record. We project these properties. We do the join based on the correlation ID, and then left outer join with the subscriber start record in my traces. I project some properties, and then I do another join. This is very interesting with the subscriber start, but I just want that record where the delivery count is the max, right? So let's say in this case, I'm limiting to up to 2 retries, but let's say you have 50 retries to deliver to the target system, right? So you don't want to see the status of 50 different attempts. You just want to see the status of the very last attempt. So if it failed in 50, that's the record you want to see. If it was successful in the 35 out of 50, this is the one that you want to see, right? So we are just joining with the last attempt, and same for the subscriber finish. I do the same because the subscriber finish is a different record. And then I project all these properties at the end, and I'm sorting by the timestamp. And again, I can filter here. So I can say when entity ID is 76, for example, I think I should be doing something here. Yep. So I can see the user with user ID 76. I can see what happened. It was successful in the different checkpoints. It was delivered in the first attempt. So all of this I get thanks to the distributed tracing with structured logging strategy that I'm using here. Are there any questions? Yeah, so all the queries are in the series of blog posts, actually. So I'm going to share again the links to the series of blog posts, and all the queries are there. And even I'm going to show you now so on my GitHub repo, which is public, you will see in the infra folder, if you deploy this, so this will deploy all the infrastructure. It won't deploy the function app, but the function app in C#, but you can build it and deploy it manually yourself. But then in the workbook, I have the serialized data here. And so if you deploy this, and actually, if you see here in the README, you can click on deploy to Azure. It will deploy all the infrastructure for you, the function app, the storage account, everything, including the workbook on App Insights, and you will be able to see the queries, the cluster queries. But if you want to see query by query, so if you go to well, let me go to the so if you go to the implementation side of my blog series, you will be able to see query by query, and each of the queries will have some comments as well that will help you to understand what's happening behind the scenes. Yep. Cool. Okay, so that was the demo. Some considerations where you're implementing this in your solution. So depending on how verbose your logging is, there might be some, well, there are some costs associated. Usually it's very large, it's usually very small. But depending on how verbose it is, you need to consider this. And there are costs on App Insights for ingestion and retention. The next one is you can configure to sample your tracing on the client side. So on Azure Functions, on the host.json file, you configure if you want to have some sampling on your logging strategy or implementation. That means that you could lose some of these tracing events. So if you don't want your logging events to be sampled, then you need to disable sampling as part of your host.json. If you don't have any sampling on the client side, also on the server side, they can be sampled. So you need to check that there is no sampling configured on your app insights on the server side. And there is also a daily cap or a maximum request per second, which you can change as well. These limits are quite high, but you need to be aware. So the telemetry channel is asynchronous and is best efforts, meaning there's a chance of you losing some of these log events. The thing is the application is keeping some logs in memory and then pushes them to App Insights. So if the app crashes in the middle of doing something, probably those logs won't be sent to Log Analytics. Or also if there are network issues, long-term network issues, you might lose some of these tracing events. You just need to be aware. So this is best efforts. You might get 100%, you might get 99.9% of your events. And because of that, this approach should not be used for auditing or billing purposes, because you know that some of these events can be lost. Any other questions? Well, if there are no questions, so as I mentioned, everything that we covered today is very well detailed in this series of blogs. So you can go and check the blog post on my series on the Deloitte website. And also you can have a look at the repo where all the infrastructure and all the code for the Azure Functions is available. Again, thanks for joining. You can follow me on Twitter or on LinkedIn. The slides are already available on my slide share here. I'll add these to the comments at the end. And thanks for joining. Thanks, and bye everyone from Melbourne. And keep enjoying the sessions in Global Azure. Cheers.